Question A asks us to calculate the number of moles of Cl minus present before any reaction occurs. And to do this, you need to know the equation moles is equal to molarity times liters. And in the problem, it gives us 25 milliliters, which is the same as 0.025 liters, and a 0.25 L molarity. So if we just multiply them together, we get 0.00625 moles of Cl. And it also asks us to calculate the volume in liters of the CO2 in the sealed container. And what we calculated was Cl minus and not CO2. So to do this, to convert this amount to CO2, we have to use stoichiometry. So in the balanced equation, there are 4 moles of Cl minus and 2 moles of CO2. And I'll put up a little equation on the screen right now. And so basically you just divide this number by 2 and you get 0.03125 moles of CO2. And now that you have moles, you can complete the step. So if you rearrange the equation PV equals N on T, you can get volume equals moles times R times temperature in Kelvin divided by pressure in ATM. Okay. Sorry that the slides were messed up, but okay, so the equation, so we just calculated the moles of CO2, so we can plug that into the equation. And the R value for ideal gas law is 0.0821, and that's the R. And the temperature given is 22 degrees Celsius. But we have to get that to Kelvin, so all we have to do is add that by 273, and we get 295. And then we divide that by the pressure, which is given, which is 0.950 atm. And so if you do the math, you get a volume of 0.0797 liters of CO2. So question B asks us to determine the order of the reaction with respect to each of the following. So I transferred the table given on the sheet to the screen, as you can see. You need to find like the exponent of the Cl, kind of. So what you want to do is find a trial where the MnO4 is the same, but the Cl minus is different. So as you can see in trial 1 and 2, 0.014 and 0.0312 are different, and these two have the same value. And so I would put the trial 2 on top because this number is larger than this number. So we get a nice whole number. So we don't really have to include these values into the equation because they just cancel out, so they don't really matter. So trial 2 had 0.0312 and trial 1 had 0.104 molarity. And so the molarity units cancel out. And then these values are the rate of disappearance of MnO4. And trial 2 was 2.03 times 10 to the negative 7th. And trial 1 was 2.25 times 10 to the negative 8th. And if you simplify that, you get 3 to the x equals 9. And that's pretty simple math. It's just 3 squared equals 9. So x is 2. And question B asks us to determine the exponent of MnO4 in the order of the reaction. So just as we did in the previous problem, so we have to find 2 trials with the same molarity of Cl, but a different molarity of MnO4. And as you can see, trial 2 and 3 have the same molarity of Cl and a different molarity of MnO4. And I put trial 2 on top this time because this number is larger than this one. So that's what I did right here. And again, we don't have to include these units because they'll just cancel out, so that's just extra work you have to do. So if you simplify this, this is 2 times as large as that, so you can just get 2y. You can see that this number is just twice as small as that, so you can just get 2. And 2 to the second is 4, 2 to the first is 2. I don't know how I did that. Okay. Well, question C asks us to write the rate law for the reaction. So using the values we got in the previous questions for the Cl, our exponent was 2. So we put Cl minus 2. Then for the MnO4, we calculated that the exponent is 1. So the exponent is also 1. And the h plus value is 3 because, as you can see, all of them are 3, so we don't really need to do any calculations. So to get the k value, we just have to plug in the numbers for one of the trials. So I ended up doing trial number 1. And so as you can see, I put 2.25 times 10 negative 8 on the left. Yeah. Question C asks us to write the rate law of the reaction. And we kind of already did this in our previous problems. So our exponent value for the CL was 2. So we put CL minus 2. And in the previous one, we found our exponent was 1. So it was just MNO for 1. But I didn't put anything because you didn't need to. It's something the first power is equal to itself. And we got the 3 for the h plus because all of the values were 3, so we didn't really need any calculations. And so I just substituted all the numbers for trial 1, and I ended up getting 0.0019 mole to the negative 5th times s. I found this out by altering m divided by s equals k molarity. So I substituted k. So I just rewrote it and said k equals ms times 1 divided by molarity to the 6 times s. And you end up getting k equals 1 divided by mole to the 5th times s. And question D asks us if it was likely that the reaction occurs in a single elementary step. And I said no, because the orders of the reaction do not correspond to the coefficients in the balanced equation.